All right, so in this video, we're going to introduce slope, okay, the concept of slope, which is a rate of change, okay? So we just recently went over rate of change. We talked about what that was and how to find it on a graph and from a table of values, okay? So when you think of rate of change, moving forward in your math classes, you need to think of rate of change in the context of slope, okay? So in this video, we're going to talk about using rise over run to calculate slope. Okay, we're going to do that like we did with rate of change from a graph. We're going to talk about the slopes of horizontal and vertical lines, and we're going to distinguish between lines that have positive slope, negative slope, zero slope, or undefined. Okay, so first thing, we're going to use rise over run. Let's go ahead and define those. All right, so rise is the difference in the y values, okay, of 2 points on a line. It can be any 2 points you choose. It doesn't matter. We're still going to be able to find the slope from that, okay? We also can call that vertical change, okay, or change in y, okay? Run is the difference in the x values of any 2 points on a line, and we can refer to that also as horizontal change or change in x, all right? Slope is the ratio of rise to run, okay? It's going to be rise over run. And again, you can choose any 2 points on a line. Now in this video, I'm going to choose the points for you, but when you're finding the slope of any line, you can pick any 2 points that you want, that you know to be on the line. Okay, so the formula, well, let's not count the formula really, but let's define the ratio here. First off, we're going to use m as the variable for slope. And like we said, it's already going to be rise over run. And we can also refer to that as change in y over change in x, okay? Or vertical change over horizontal change, all right? So we're going to do number 1 here. We're going to go to the graph and do number 1. We're going to draw the triangle, the rise over run triangle like we did with rates of change, okay? So let's go to the graph now. So let's look at the solid line first, okay? We want to determine the slope of the solid line. All right, so first thing we want to do is we want to draw our triangle connecting the 2 points that are on the line. Okay, and you can see that in green there. Okay, remember we want to do vertical change, okay, or the rise first. So the difference there in the vertical change is 3. We're going up 3 units. From here we go up 1, 2, 3. So that's the rise or the vertical change. The horizontal change is going to be 2, okay? So the slope is that ratio, rise over run. So the slope is 3 over 2, and it's going to be positive, okay? Positive 3/2 or positive 1.5, okay? For the dashed line, you want to draw your triangle connecting the 2 points, okay? And we want to count. From the point here, the vertical change is going to go, we're going to go up 1, 2, 3 again, 3 again. And the horizontal change, it doesn't matter which point you start with, but we're going to count 1, 2, 3, 4, 5. So that's 5. So my run is going to be 5. So my ratio there, my slope is 3 over 5, or 3/5, okay? And that one's going to be positive as well. So one thing you want to notice, those lines are all rising from left to right. It's going up from left to right, and those slopes are positive. So any line that goes up from left to right is going to have a positive slope. Okay. All right, so to verify and to review here, the slope for the solid line was 3/2, which is positive. The slope for the dashed line is 3/5, which was also positive. Okay. Let's go down to number 2. Okay, we've got a solid line here. Again, we can already tell that line's going to have a positive slope because it's rising from left to right. And let's see what happens with the dashed line here. Okay, so let's go to the graph. All right, so let's start with the solid line here. Okay, again, we can tell the slope's going to be positive because the line is going up from left to right or rising from left to right. All right, so we're going to draw our triangle first. Okay, our vertical change, our rise is going to be positive 2. And our run, our horizontal change is going to be 5, okay? So that slope, remember the rise comes first, so it's going to be 2 over the run of 5. So the slope there is going to be 2/5. All right. The dashed line, okay, this line falls from left to right. So the slope here is going to be negative. It's the first time we've seen one of those here. So let's draw our triangle, okay? So our vertical change, we're going down Okay, 3 units. We're going down 1, 2, 3. So that rise is going to be -3 now. And the run is going to be +2. Okay, so using rise over run, the slope of this dashed line is going to be -3/2, or -1.5. Right? So again, notice positive slopes go up from left to right. Negative slopes are going to go down from left to right. All right, so that's number 2. Let's move on to number 3. Okay, so here we've got a different kind of line. This line is neither rising nor falling from left to right, and this line is neither rising nor falling from left to right. Okay, so the slopes here are going to be a little bit different. They're not going to be positive, and they're not going to be negative. Okay, so let's go look at the graph. So starting with the solid line here, okay, if you'll notice, in this case, we don't have any vertical change. Okay, there is no vertical change. There's only horizontal change here, because this is a horizontal line. All right, so when we're finding slope, all right, so the rise, because there is none, we're going to call that 0. The run, it really doesn't matter what it is, but between these 2 points, the run is going to be 6. Okay, you can divide 0 by other numbers. Your answer is just going to be 0. Okay, so the slope of a horizontal line here, the solid horizontal line, is 0. Okay. And looking at the vertical line, okay, if you'll notice, this is a vertical line because it's going up and down. This time we do have a rise, okay? You can call it 6 if you're going from the bottom point to the top point, or you can call it -6 if you're going from the top point to the bottom point. It doesn't really matter. So our slope is going to be the rise, which is 6, over. There is no run, okay? There is no horizontal change. There's no movement at all from left to right. And so we're going to divide by 0. Now, if you want to prove this by using a calculator, you can't divide by 0. Okay, division by 0 is what we call undefined. So vertical lines, because there is no run, the slope is going to be what we call undefined. All right, and you can use the symbol for the empty set here. There is no answer for the problem, so the slope is undefined. Okay, so vertical lines have a 0 slope. Excuse me, horizontal lines have a 0 slope. Vertical lines have a slope that is undefined, and that's always going to be the case for horizontal lines and for vertical lines. All right, so that's the answer for number 3. So last thing we want to do here, we just kind of want to clean everything up. So the types of slope you can have a positive slope, okay? And we say the line rises from left to right. It's always going to look something like this. The amount to which it rises from left to right can change. It can be a lot steeper or flatter, but it's going to be going up as we move from left to right, okay? You can also have negative slopes, which fall from left to right, okay? Again, the steepness, which we'll talk about in the next section, can vary. It can be very steep going down from left to right, or it can be very flat going down from left to right, but then, it is going to fall or go down from left to right, okay? 0 slope occurs when we have horizontal lines, okay? And undefined slopes come when we have vertical lines that look like that, okay? So if you can remember this, it's going to make, looking at a line and determining whether the slope or the rate of change should be positive, negative, 0, or undefined a lot easier. So make sure you try to remember these 4 concepts, okay? And that's our introduction to slope.